So what's my alternative approach to this? Well, we proved it from left to right. Remember from your trigonometry identities? We can prove it from right to left. That means we can differentiate this and show we get that. That's the other method, okay? So in doing that, I'm going to start off with the right-hand side, and I'm going to let y equal arc sine x, okay? And then I'm going to differentiate that, okay? To do that, this is the method. So we write that as sine y is equal to x. Remember, if y equals arc sine x, do the inverse of that, which is just sine on both sides. So sine y is equal to x. And then we differentiate both sides, okay? We can do so implicitly if we want, or we can just write it as x equals sine y, and then do dx dy is equal to cos y. Probably easier like that. Now, because we want to find what dy dx is, y is this in terms of x, so we want to find dy dx, then of course our answer is just going to be 1 over cos y. That's the derivative of this. But we don't want it in terms of y, we want it in terms of x. Okay? So the thing to do is to, let's just put it up here, write it as dy dx is equal to 1 over, and that's going to be root 1 minus sine squared y. Can you see where this is going? Okay, I really hope so. Are you happy with that to that? I really hope so, because you need to be, year 13 level, okay? And of course, sine y is just x, so that is just 1 over root 1 minus x squared, okay? And you can also explain that when you differentiate a constant term, you get 0, okay? And that is it, okay? That is it. We've proved it from right to left, okay? Probably simpler to do that, but in a way it's nicer to go left to right, because if you read it as prove this equals this, really wants you to do it left to right. But the trouble is, in some areas of mathematics, it can be too hard to go from left to right. And what we do instead is we go from right to left. And that's where we use the result that because integration and differentiation are self-inverses of each other, if we prove from right to left, that must mean the left to right case must work, okay? I hope you enjoyed that as much as I did.